So, good evening everyone and welcome to today's webinar. I'm your host Santosh Sharma from IPA headquarters Delhi. We had a very fantastic sessions on 14th to 16th March with experienced speakers. Today, we have the last session on modern trends in plumbing. I hope you will enjoy it. Now, I would like to show you a video of WPC Chairman Tom Bingley in which he highlights World Plumbing Day and why the plumbing profession is important.
Happy World Plumbing Day. I'm Tom Bigley, World Plumbing Council Chairman and Director of Plumbing for the United Association of Plumbers and Pipe Fitters from the United States and Canada. On March 11th, every year, people from all over the world will celebrate World Plumbing Day. This all started 12 years ago when the WPC established this date to bring awareness to the public that plumbing cannot be something we take for granted. We want to show our communities the responsibilities that plumbers have in protecting their health and, more important, educating them on ways to conserve our dwindling resources for the future. I'm here today at my nation's capital, Washington, D.C., at the United Association of Plumbers Local 5 Training Center. Here in the lobby of history are some of the early plumbing systems of this city. Although our country is young compared to the plumbing systems of India and Europe, our infrastructure is crumbling and in need of repair and replacement. That's why I chose today's location for World Plumbing Day's message. If we want safe, reliable drinking water and proper sanitation, it all starts here with training the next generation of plumbers. Every year, young adults from all over the world must decide on a career path for themselves and their families. It is essential that we promote the plumbing industry as a profession to ensure that we can continue to provide a good quality of life for the next generation. Here at the Plumbers Union, we take over 10,000 new apprentices every year at over 250 state-of-the-art training centers like this one that are scattered around the United States and Canada. These classes not only include waste, vents, and water systems, but also medical gas, backflow prevention, safety curriculums, and water reuse. Here in the rainwater harvesting training module, this facility captures all the rainwater and repurposes this for the flushing of water closets, urinals, and all the water to supply the wet training laboratories for teaching. By facilitating the training needs of our contractors and end users, we are expanding their employment opportunities, which makes it a clearer career choice for the next generation of workers. Fair wages and benefits, continuing educational opportunities, and not to mention a safe workplace environment will continue to attract critical workers for the future. It's 2022, and we are talking about the pandemic, which has killed close to 6 million people, and yet we are silent on the fact that over 100,000 people die every year from inadequate water, sanitation, and hygiene. World Plumbing Day raises awareness of this terrible but preventable statistic, but more needs to be done. The perception of good plumbing deserves to be recognized as a frontline solution to preventing diseases from taking away the lives of our children. Here at the World Plumbing Council, we work with global organizations like the World Health Organization, Messe Frankfurt, IWISH, and the World Skills Competition to support new technology and training seminars that promote clean, sustainable water and sanitation. To increase our voices, we need your help. Get involved by joining the World Plumbing Council. Share a link on your Facebook page or request proclamation from your country that recognizes March 11th as the World Plumbing Day. The more publicity we get, the more attention will be drawn towards funding to build critical plumbing infrastructure throughout the world. Also this year, the World Plumbing Council Conference will be hosted by China in beautiful Shanghai on October 13th to the 15th. Please join me and our entire World Plumbing Council family in exploring new products, new technology, and plumbing practices. The world is a small place. We must all work together to preserve our resources for our children and their children. Help me in celebrating World Plumbing Day by thanking all the plumbing installers, the plumbing manufacturers, the supply house workers, plumbing engineers, sewage and water treatment plant workers, and especially our plumbing instructors, for without their sacrifices and efforts, we would not be able to train the next generation of skilled plumbers. Thank you, and remember that the plumber protects the health of all nations.
Happy World Plumbing Day!
Now, before we go further, wherever you are, let's stand all for the national anthem.
जन गण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
So, first of all, I would like to express my gratitude to everyone who has taken the time to join us today in our previous sessions. Today, as we discussed about modern trends in plumbing, throughout the session, your active participation is very important. So, first of all, I would like to request you, please be on mute so others are not disturbed by the background noise. And throughout the presentation, you can write your questions in your chat box or in Q&A sessions. After the presentation, our team member will ask those questions to our speaker. Now, let's move on. I would like to over to Mr. Milind Chete, Chairman of IPA NEC Chapter and Student Chapters Convener. He will share the opening remarks. Now, please welcome. You are mute. You are on mute, sir.
Sorry, am I audible now? Thank you, Santosh, and a very good evening and a very warm welcome to all for this fourth and final webinar in the series of webinar organized for specifically the student chapter members to celebrate the World Plumbing Day. If you remember, in the first seminar, we learned about the basics of plumbing, whereas in the second webinar, Dr. Sunil Kute spoke about the career opportunities in the plumbing field. Mr. Rahul Darfare yesterday elaborated upon the good plumbing practices, which was the third in the series. And now today, our expert speaker, Mr. Srinivas, will be speaking about the modern trends in plumbing. Dear delegates, if you see the structure of today, then they are becoming more and more bigger, both vertically as well as horizontally. More and more complex buildings are coming now, structures are coming now. And now you can see buildings of various odd shapes, like a coin shape or an egg shape or a pyramid shape or any other abstract shape. See, while planning the plumbing services for such an architectural and engineering marvel, we need to brush up our brains, do a lot of brainstorming so as to cater to the requirements of these buildings. The system needs to be designed in an innovative way using innovative products, which eventually becomes a trend, or you can say a modern trend. Today, if you see, the convenience coupled with the desire to save money, to safeguard the health, and of course, to preserve the environment are driving the top trends in the plumbing industry. Of course, the COVID conditions have also brought new perspective to the way we are using the washrooms. Now, you will see that the modern toilets now use smart technologies to analyze your blood sugar levels, measure body temperature, and even take the blood pressure of the user. So these are some of the innovative technologies or innovative products which are coming. Now, if you see the smart toilets which are set to flourish, they are equipped with several functions like auto flushing, overflow protection, water saving features, self deodorizers, sensor enabled commercial LED lightings are inserted in that. They are self cleansing, and there are many more features in that. Today, you will also find many innovative, space saving and cost effective products used for water supply, sanitation, and stormwater system. With this background, without wasting any further time, now let us move on with our program and hear about modern trends in plumbing from our expert speaker, Mr. B. Srinivas. Over to you, Santosh. Thank you very much.
Thank you so much, sir, for sharing the valuable remarks. Now, I would like to play first the sponsorial video.
KPT, Flow Infinite. Modernization is an indispensable aspect for any society to thrive, grow, and develop. Rapid urbanization requires robust infrastructure development and building construction. Every industrial and commercial construction requires a non-corrosive and eco-friendly advanced plastic piping system. Here comes KPT Piping Systems Private Limited, an ISO 9001-2015 and ISO 14001-2015 certified company with the advanced European technology PPR piping system. Operational since 2008, KPT is India's #1 industrial PPR piping solutions provider. A leader in polypropylene random copolymer piping systems, PPR Piping System has a state-of-the-art multi-specialty piping manufacturing facility and uses non-toxic food-grade, highly strength, fusion weldable raw material for the production of its piping systems. To ensure world-class quality, KPT brings to you a piping system made with R200P PPR raw material, 100% Hyoseong from the Republic of South Korea. PPR pipes are eco-friendly and 100% food-grade material and resistant to most of the chemicals. PPR piping system is now widely used in the fields of drinking water, compressed air, cooling towers, firefighting, acids, RO, DM, ETP water applications, offering a longer lifespan of 50 years. With world-class PPR raw material and state-of-the-art production facility, KPT has successfully completed 2,500 plus complex projects for various industrial, commercial, and government organizations. Our piping system is now running for most critical applications like data centers, injection molding factories, and chillers all over India. Our product ranges: pneumatopipes for compressed air, green therm for water applications, thermoplast for firefighting system, KPT's manufacturing facility, lab, infrastructure, etc. KPT has a full-fledged and fully automated manufacturing facility with a capacity to produce 15 metric ton pipes per day. The unit has a fully equipped lab for material testing and quality assurance. The company adopts a stringent quality control process to ensure our customers get only the best anytime and every time. Our achievements: winner of India 5000 Best MSME Award for outstanding contribution in quality and excellence in the realm of customer satisfaction. Pride of Bharat for the year 2021 for the most trusted pipes manufacturer and suppliers of the year. Our esteemed members: FIEO, Federation of Indian Export Organizations; CII, the Confederation of Indian Industry; EEPC, Engineering Export Promotion Council. We believe innovation and quality are the key to deliver world-class products. For over 13 years, we are working to deliver excellence to all our stakeholders. KPT, Flow Infinite.
So this year, we organized 4 student chapter webinars. On 14th March, Basics of Plumbing. On 15th, Career Opportunities in Plumbing. And on 16th, Good Plumbing Practices. Today, we have a session with V. Srinivas, who will spoke or discussed about modern trends in plumbing. In addition to the student chapters, we also organize regional webinars in 8 different languages: Malayalam, Tamil, Telugu, Kannada, Marathi, Gujarati, Bengali, and Hindi from 2nd March to 10th March. And on 11th March, we held a national webinar to celebrate a World Plumbing Day. These all recorded sessions are also available on our IPA website under virtual technical sessions. Now, today is the last day of social media contest. In this, you can share your experience on these 4 aspects: reuse of water from RO reject, fixing leaks, reduce water footprint, other innovation, daily chores in kitchen and bathroom, and submit your experience to our social platforms or our email acep@indianplumbing.org. So you have a 4 social media platform to submit your entries, and the top 3 will get the cash rewards. So hurry up, you still have some hour to grab this opportunity. Now, I would like to introduce today's speaker, V. Srinivas. V. Srinivas is CEO, Synergy Infra Consultants, Hyderabad. He is an MTech in electrical engineering, worked for development of space, Government of India from 1985 to 1995 in planning of various ground services for space programs like PSLV, GSLV, etc. Established Synergy Infra Consultants Private Limited in year 1996 and worked on various projects like healthcare, residential, commercial, IT, retail, etc. Besides defense projects of national importance. He has a master trainer and energy conservation building code of India, and he is also the IPA past national executive committee member and a technical committee member. So I would like to invite V. Srinivas.
Thank you very much. Good evening, everybody. I hope you're all having a nice time after the college. You're able to hear me? Huh?
Yeah, yes.
Okay. So I think you all had a wonderful time with the college. And really, I appreciate your interest to learn plumbing, which we feel it is a very much essential. And let me tell you, being an electrical engineer, you can understand why I have come to the plumbing line or the fire safety, because there is a huge dearth of manpower, especially the plumbing engineers in the country. Plumbing is not a subject which is taught properly, as a curriculum in any of the colleges. So that is where the efforts of IPA, Indian Plumbing Association, are commendable, and the kind of codes and books what they have brought out for the improvement of awareness among various stakeholders, including either the students or the architects and engineers, is really appreciated. And I would like to talk about, I'm sure you all had 3 different sessions the last 3 days about the basics of plumbing and the career opportunities in plumbing and the practical aspects of plumbing, which are 3 interesting subjects. And I'm going to present you about the modern developments in the plumbing. So just give me, I can now, you're able to see my screen, I hope. Right? So first of all, I all would like to look at the World Plumbing Day. First of all, congratulations to all of you, because 11th March is conducted as a World Plumbing Day, which is celebrated. You also have seen the WPC chairman's message. If you see the World Plumbing Day logo, can you look at, there are 4 aspects which are very, very critical. There are 4 leaves of the plumbing. That is not only water, but the energy, environment, and health. So the water is directly related to the energy. We call it as water energy nexus, the connection between the two. If we have to carry water to a long distance, there's a lot of energy to be spent. And also the good water or bad water, whatever, the wastewater. So that can create some kind of harmful effects in the lakes, nalas, and stormwater drains, wherever the water is let out. So it has got direct environmental impact. And the next part is, third thing is health. I don't know how many of you are aware, the SARS virus, which was around, 7-8 years back, it started from Hong Kong, which has threatened the whole world. In fact, that was before the coronavirus. This was really, a very, very, problematic virus, which has spread very fast. And this has started because of a bad plumbing in one of the toilets in Hong Kong. That is what they have traced out. So if you understand, if you don't do a proper plumbing, our health is going to get affected. So when water is related in so many ways, like energy, environment, and health, unfortunately, the plumbing is not given its due importance. So what is the plumbing? I'm sure you all have understood by this time with different lectures. Basically, it is related to the collection, storage, and conveyance of water and reuse, recycle of water or wastewater, whatever is happening at any particular location. And if you look at it, we have only around 2.5% of the world water resources is really potable. Potable means drinkable. Otherwise, we can't use the 97.5% or 98% of the seawater, which is not really usable. So in such a case, this water has become very, very precious. From where we get water? We get mostly the rainwater. That is what is the water source basically anybody can have. And the water, whatever we take out from the bore wells, is also because of the rainwater, which is percolated down into the soil. So with this brief background, let us understand what are the, now the subject is modern trends in plumbing. What kind of trends? You see, we have just understood from the logo itself that there are three aspects, with respect to the plumbing, water conveyance. One is energy, other one is environment, and other one is health. So these three have got the highest priority today because of global warming issues. And then there is a lot of, stress on energy efficiency. So the first and foremost thing, whatever the modern trend we are talking about, we should be able to save water. I Save Water is one of the missions which is started by IPA. I'm sure you are all aware. Otherwise, please have a look at the videos of the I Save Water from the indianplumbing.org website. You can understand different methods of energy, the water saving methodologies which can be implemented. So how do you save water? We cannot, please let us understand, we cannot create water. This is the most problematic thing. We can't, even though we have a lot of oxygen in the air, but you cannot produce, we know that H2O is the water, but you cannot combine, create water like whatever you can. Most of these resources are like that, either even the electricity for that matter. So naturally we need to depend on how to save water and how that can be, whatever the wastewater that can be reused, recycled and reused. So the reduce, recycle and reuse, basically the 3 R's are the funda for the water conservation. So you look at any kind of green buildings today, or you must have heard about the green buildings, from IGBC, Indian Green Building Council. They give very high importance towards water conservation and energy conservation. Understand, whatever water you save, you are indirectly saving the energy. So both ways it gets impacted. I'll also show you some of the case studies how it can be impacted. So how do you save? One is by trying to reduce the consumption. You can save water, you can recycle and reuse, or otherwise use some sort of water efficient fixtures. How the water is getting wasted in most of the premises, usually when you have a tap, for example, you totally open, you put a big pipeline, bigger tap, and then open it out, you will get a lot of water. Suppose you try to reduce that water outlet itself, then I'm sure even that, if you are able to meet the end requirement, then I'm sure that there can be a lot of water that can be saved. So what kind of water efficient fixtures like aerators and other things which can save water, and again indirectly they can save energy. And the most important thing is, in all these things, also with respect to the energy saving, we are going to talk about how the plumbing with respect to water, how it is going to affect the energy, environment and health, and the renewable energy. So most of the hot water systems, we can try to use renewable energy. Not only hot water systems, desalination. We just discussed that 98% of the water is not a potable water. Suppose it so happens, if you are able to, what is the problem? Why it is not potable? It is all, saline. Basically, we can't use that kind of salt water. Suppose you desalinate that water. What is the limitation? Why we are unable to do is because of the power consumption, enormous amount of power consumption required to produce desalinated water. But if you are able to do it with a limited energy by using renewable energy, for example, then definitely there will be a lot of water that will be available to all of us. One of our, who is that? I think the Finance Commission chairman, he was talking about it, that by 2050, probably there may not be any dearth of water in the world. Because if we are able to harness solar photovoltaic energy, I'm sure then the water desalination can become, very cheap, and naturally the water availability can be improved. But we cannot assume that today, because there may be a lot of other requirements for the electricity as such. And then we talked about, whatever the water conservation and other things. We also have to make, just a minute. We also have to see that, what kind of materials which will help in longevity of the systems so that frequent replacements will not happen. These are all the things in the plumbing and eco-friendly piping materials. And also what kind of, see, I'll tell you, most of the studies done on plumbing, they were all done by Dr. Roy Hunter in 1940s. Even though there were a lot of studies done, but they are not in a very scientific manner. Today, even, the World Plumbing Council or IAPMO has identified a number of opportunities basically for the research in plumbing. I don't know how many, there are around 140 subjects that have been identified, and there is a huge amount of work that needs to be done, so that we can bring a lot of change in the plumbing systems. So what kind of latest technologies we can look at it? Probably, water meters, for example. Water meters was very, very expensive some time back, but today we have digital water meters, which can be integrated through our building management systems. And, we can collect a lot of data, and we can understand the trends of water consumption. And by doing that, we can indirectly control our pumps and pumping systems and try to save energy. So we'll look at, some of these systems when we look at the whole gambit of modern plumbing. So let us see what is the water supply. What are all the resources we have? We have municipal water, groundwater wells, rainwater, harvested rainwater, or otherwise condensate water, where high humid areas, for example, you take Burj Al Arab or Burj Khalifa, they get almost around 5 lakh liters every day, around 3.5 to 4 lakh liters every day of air conditioning condensate water, which they try to reuse again as a potable water, because that water is really pure, because it is almost taken out of the humidity. Because when you use air conditioning systems, if there are some mechanical engineers and who have studied the thermodynamics, they can understand that when you have to take out, the temperature from the air, you also have to take out the water molecules. Otherwise, you cannot easily take it out. So for that purpose, then whatever the water molecules that are taken out, they become condensate. So that condensate can be reused. There could be, see, you can understand, of course, it's a very big project like Burj Khalifa, Burj Al Arab, but even there, even normal projects, what we see in a project of around 1 million square feet, we are able to get at least around 10 to 15,000 liters of water, very pure water daily. So the rainwater harvesting, again, sometimes we get more rain, sometimes we get less rain. It is not completely a dependable system, but if you can plan your storage in such a way that you collect the entire rainwater whenever it rains and then reuse the whole thing for throughout the year. There are a lot of houses which are being now worked out in this manner, and some small communities who are trying to get the fresh water only from the rains, and then they try to use the recycled water basically for the flushing and other purposes, otherwise for gardening and things like that. So this is has become already a reality in many of the communities, and this is going on. And water conservation is concerned. So as we are discussing how to bring down the demand can be brought down, by using efficient fixtures, reduce the use of water itself. So by using efficient fixtures, we get a lot of, where generally a normal tap, earlier it used to be around 10 LPM, 8 liters per minute or something. Today we get it for around 3 liters per minute, or, even less than that. And we also have time-based operation, once you press it, it will deliver only to certain amount of time, or otherwise you might have used a lot of, sensor-based taps. So you put your hands, then automatically, based on the infrared activation, the tap gets opened and it will be there for a very small duration. So you will try to reduce on the wastage. And the other one is xeriscaping. Xeriscaping is something where you have to do landscaping, basically, which do not need requirement of water. So as a green building, they propose to have the kind of plantation which do not need a lot of water. So that is what is called xeriscaping. And the other one is recycling. We get, when we are using, for example, 135 liters is what NBC says per person in a residential building, and 45 liters per person in case of a commercial building, like an office building. Out of that 135 liters, except for 5-6 liters which we consume, the rest of the water in some way or other, it will again go back to the treatment plant. If we have a treatment plant, if we don't have a treatment plant, then entire thing will go waste. It will go again into the drains, and then it will get into the ground. Whether the problem is with that kind of wastage where we have high biological oxygen demand and chemical oxygen demand, it will also pollute the soils. So that's why the pollution control boards and the governments, mostly they insist on having a sewage recycling plant. So once you do the recycling of this water, that can be reused for flushing and gardening. I don't know how many of you had been to Singapore. Singapore do not have any water. Generally, they get their water. They purchase 40% of their water from Malaysia. They have an agreement with Malaysia, I think till 2030 or something. And then they have to find their own means of, water resources and other things. So what do? They get around 30 to 40% of fresh water they buy from Malaysia, and the rest of the entire 60% of water is only storm water, which is collected from rains, and then recycled water, STP, sewage recycled water. Everything is combined, and then they call it as a new water. This is called a new water in Singapore, and that is also used for potable purposes, that is for drinking purposes. You don't get, if you go to any hotel or any place, you get only that kind of water. Even if you get bottled water, mostly it is all, after treatment of the entire water. But the only problem is the cost of recycling, because they use very high efficient membrane bioreactors to do that kind of, to get that kind of water quality. So naturally, the cost of the installation as well as running costs are very high. We will not be able to afford to that level. So what we are trying to do is we'll have recycle, but again, try to reuse. If you look at some of the codes like IAPMO standards or some of the international codes, they say the recycled water can be used only below ground. Below ground applications means like drip irrigation, for example, where it doesn't come in contact with the human bodies. But with the kind of strict guidelines what our NGT, National Green Tribunal, has issued, which is being followed by the pollution control boards across the country, they say the BOD level should be less than 10. With that kind of BOD level, even if we get in contact, nothing is going to happen. So definitely, that water can be reused safely for flushing. May not be for, definitely for storing for a longer duration. Storage for longer duration, again, it can develop some kind of, bacteria and other things. So it is not advisable to do that. But if you can immediately reuse for flushing as well as for gardening, there will not be any harm. And the other one is rainwater collection. Rainwater capture, even there are a lot of guidelines with respect to rainwater collection. You have to have at least minimum 15 minutes of rainfall or 30 minutes of rainfall, depending on different states, need to be stored within the premise itself. That means you have, suppose you take Hyderabad conditions where I live, we get around 50 mm per hour as per standards, but now that has gone up to around 100 millimeters per hour. And if we have a catchment of around 1,000 square meters, then we can see what is the amount of water that is being collected, and that can probably, can be stored partly as a part of the structure with an RCC structure, and where it can be reused again for the requirements of households, or otherwise it can be put back into the ground, underground, to recharge pits where it can probably, recharge the groundwater. So that can be done. And recycle is solar desalination will go for recycling, and whatever the condensation that is there, that also is reused. Now, I would like to focus on one of the important developments that has happened during the last, at least what I have seen, is with respect to hydropneumatic systems instead of regular gravity-based systems. We are looking at a lot of high-rise buildings. That's where the more focus is on with respect to energy. This is not with respect to water conservation, but it is the first one, it is respect to energy conservation in this system. So what will happen? Usually you are able to see this figure, right? So you have traditionally a overhead tank. There will be some underground sumps. Water is pumped to the overhead tank and it is taken by gravity. So what is happening? Suppose this is a project of suppose around 21 floors or 22 floors. Whatever the water requirement of the ground floor person or first floor person or second floor person, you are pumping out totally to the top of the building. That means you know that the energy is directly related to the discharge and head. Head means whatever the height. Of course, there will be, this is the static head. You may also have some velocity head, and that is called the frictional head. So that is the losses in the system. So based on that, you work out. But the most important and predominant thing in this kind of system is static head. So 22 meters is around 60 meters or 70-meter tall building. So 7 bar is the pressure. Every 10 bar is roughly 10 meters is roughly 1 bar pressure if you take it. Then it will be almost 7 bar pressure multiplied by whatever the requirement of water. Suppose that means even though the guy is within the 3-meter height, that means his pressure requirement is basically for the pumping is only 0.3 bar or 0.4 bar, but still you are spending energy to pump the water up to 7 bar and then reuse it, use the water. So what is happening? Instead of using it here, whatever the discharge requirement, suppose he needs around 500 liters per day. So this 500 liters per day, which is supposed to be at 0.4 bar, it is now being pumped out at same 500 liters up to 7 bar. So that means it is going up by almost 15 times. So your energy consumption also will go up by 15 times. So this is why instead of going like this, you try to see, this is the general thing. Here, what will happen? The overhead tank, there is normally a type of, distribution which is coming down, what you can see. But here also, what will happen? The pressure will go beyond. See, the moment you go beyond, generally, most of the plumbing fixtures, they are designed to work satisfactorily up to 5.5 bar or 80 psi. Anything above that, the plumbing fixture is going to fail. But in India, we have seen some of the manufacturers, whatever they do, they can't work even beyond 3.5 bar or 4 bar. Our National Building Code of India specifies the maximum pressure should be restricted to around 4.2 bar. So we go up to 4 bar maximum, even though 5.5 bar is specified by international standards. We look at around 4 bar based on the National Building Code of India. If it is 4 bar means 40 meters height, that. But this building is 70 meters. Then what will happen when you are taking it by gravity? The lower levels where there are almost up to 30 meter of height, they are subjected to very high pressures, and there is a possibility of failures of fixtures. And some cases, I have some photographs, I couldn't show them now, where because of high pressure, they can rupture wash basins. They can, make WCs to blast, like, they break off completely, suddenly, and with the impingement of that kind of pressure of water. So that's the reason we need to input a PRV, pressure reducing valve. So what is this pressure reducing valve does? We'll see in the next subsequent things. It reduces the pressure. But what it will do by reducing the pressure? You see, it's like a brake in a car. We'll discuss that about in the next subsequent part. So this is how there is a, without any, this one, and also the top floors will not have required pressure. So what will happen? You need to give a booster pump for that. Not only you are pumping out all the way up, and plus because of the top fellows, you have to give a booster pump, because again, it is stored in the overhead tank. The pressure is available is only not more than 0.5 bar, 5 meter height, probably the overhead tank could be above the terrace. But it's not sufficient for a good shower and other things. So you need to boost up to at least 1.5 or 1 bar pressure. So that means 2-3 levels will be pressurized. One level will be without any PRV. Other 2 levels could be with PRV. But so this is what, a case study has been done. Instead of going for a gravity-based system, we can also do another system called hydrodynamic system, where there is a pump which will pump out only, you can see here bottom lines, whichever is going from bottom to the top to half of the zone. This is one system which can be used for the whole building as well. But these pumps, whatever we are doing, implementing here, what will happen is the pump will have a small pressure vessel, and I'll show you that picture also of the pressure vessel. Let me just check before we go into that. You see, it's something like this. There is a pressure vessel and this is a piping. So this tries to maintain the pressure uniformly, because what will happen when you are taking out water, there will be a pressure drop. So that pressure will be maintained constantly by this kind of pressure vessel, and the pumps are one thing which will keep pumping it whenever the pressure drops down in the vessel. So what will happen? Suppose the first floor fellow needs the the water up to 500 liters, but still depending on, because this pump will have a variable frequency drive. If any electrical engineers are there, they can understand well. So now you can understand plumbing is no more plumbing alone. You need to have a knowledge of electrical and mechanical engineering, and also as we go on further, we need to have even the background of electronics engineering, and it is becoming really high tech. So you need to understand, you need to have a variable frequency drive, and this particular variable frequency drive will regulate the speed of the pump. The moment speed of the pump is reduced by half, your power consumption is to the cubic of speed of the pump. That means if it reduces to half, the power can come down to 1/8 of the requirement. Suppose it is taking around 8 kilowatts of power, it will come down to 1 kilowatt. So naturally, the head of the speed of the pump regulates based on the head requirement again. So the moment first floor fellow needs water, the pump will deliver only that much head, suppose. Then your pump the power consumption can come down. So this is one most important thing, which has resulted in a lot of energy savings. I'll also show you some of those calculations, how it can be done. In this particular case, which was done by our friends from IPA, I think Rahul Darpale and all, they have done this exercise, where they have done a 22-storied building, 11-story into 2 numbers, and top 11 floors are supplied by hydrodynamic gravity-based system, and then the other levels are supplied by hydrodynamic system, and by which they are able to bring down the initial cost by almost around 26 lakhs by using, instead of gravity alone, they could have an initial cost savings. And also what we had worked out subsequently is, depending on the number of risers, if it is only over a tank, the power consumption for this particular project, it needs around 1.58 kilowatt, or total energy requirement is around 8 units per the total per day, or whatever it is. But same HPS, with gravity, if we make it into 5 zones, that means around 4 floors are fed from one particular zone, then what will happen? The power consumption can come down to 5 units. If we are able to, sorry, this is 3 zones, and if you are able to make it as 4 zones, then power consumption can come down to 4.95 units. So something like this. And same way, but what we have seen in this particular thing is, whenever we are trying to pump it up, definitely we need, our requirement of pressure is only 1.5 bar. But we are taking a hydraulic zone, that is what we call it. We take it around 6 to 7 floors as one zone, because we can't put a PRV, pressure reducing valve, for every place. Suppose you put up, around 6 or 7 floors together, the bottommost fellow with a hydrodynamic system will have the required high pressure, whatever is required to meet the requirement of the topmost fellow. So that means, here I'll show you once again this drawing. So here, if you see here, whatever the bottom to top, this line, whatever you see, topmost fellow, he needs around 1 bar of pressure. Then if it is around 7 floors above, 7 into 3 meters is 21 meters is the total height. Then the pump will have 4 bar pressure. Then what will happen? The lower level fellow also, he is getting 4 bar pressure. So then what we need to do? Lower, we have to reduce it to some other zone and put a PRV. Even then, again, this fellow may need around 2.5 and lower, so that then only we get the minimum pressure at the bottom point. So what will happen? That means we are going to provide pressure reducing valves. What is a pressure reducing valve? What will happen here? Pressure reducing valve, definitely the moment you reduce pressure, you can see this screen here, at a tap or a shower or whatever it is. Suppose it is delivering at 3.5 bar pressure, 113 liters. Then at 4.5 bar pressure, it will deliver 136 liters. At 5.5, it will go up to 151. So if it becomes double the pressure, we lose almost 50% of the water. Generally, what will happen whenever we are taking shower, even certain flow rate is good enough. But if you are getting more than that, what will happen? It will all go waste. So that's why it is definitely important to put up a pressure reducing valve. But pressure reducing valve is what? We are trying to increase the pressure on one side through the pump and reducing the pressure from the other side. So why this is a PRV detail. There will be, a small spring and a diaphragm inside, which gets opened based on the incoming pressure. If the pressure is, the set point is something like 1.5, it can bring down whatever may be the incoming pressure. If it is in 1:3 ratio, beyond that it cannot work. If your output pressure requirement is 1.5 bar, input could be 4.5 bar. Otherwise, you need to put 2 such PRVs in series. That is what need to be done. 1:3 is the maximum recommended by most of the manufacturers. What will happen? You could see a lot of things in this. There is a washer, there is a spring, there is a diaphragm. And what will happen? The moment, any one of these, they're all mechanical components. They can worn out over a period of time. They can get rusted. They can, malfunction. The moment they are malfunctioning, then your system is subjected to very high pressure. This is one problem. The failure of a PRV will be subjected to very high pressure, where again, it is not only the problem of wastage of water, there is a danger of breakage of fixture units and other things, failure of the fixtures. So that is why the PRVs should be restricted to the as much number as possible. And also any kind of dust particles, there is a cartridge, seed cartridge and other things. So this will, any kind of particles will make them inoperable. So inside, that's why we need to have a strainer. Before that, strainer will take out any kind of dust that is entering the water line. But the moment you have a strainer, there is a requirement of regular maintenance for the PRV. So we need to have a PRV which is wasting energy and which is also can malfunction and create a problem, and it needs regular maintenance. So there are 3 disadvantages with this. But that's the reason you have to make sure when we are looking at how the pressure reducing valve. If we are talking about only gravity based systems, that is what is the majority of the cases. We need to end up in number of PRVs, but with hydrodynamic systems, we can reduce. And also I'll come back to some more energy savings with the studies, what we have done. So here, without a PRV, second figure, whatever you see, it is not at all recommended, but you can have PRVs to bring down the pressure, because top floor, if it needs 1.5 bar, bottom fellow needs to have at least around 8 bar or 9 bar, depending on the height of the building. So when you have, maximum 3 PR, suppose you want to get pressure reduction, it's a tall building. You have one pump which is pumping up to 10 bar pressure. Your requirement is 1 bar. So can you reduce from the lower fellow? It's a 100-meter building. So that means 10 bar is a topmost fellow, 90-meter building. 9 bar is the static head and 1 bar you need residual head. So that means 10 bar is the pressure requirement. The moment you have 10 bar at the bottom apartment fellow or bottom office fellow will get 10 bar pressure. So I have to bring him also down to 1 bar. How do I do that? I have to put 2 PRVs in parallel, because it can work only between 1:3. The first one should be 10 bar to within 3 bar. So that means 1:3. And the second one is 3:1. 1:3, that is 1 bar. So you need to have 2 PRVs in series. And even any PRV fails, again, it's a problem. It becomes direct. So there is nothing you can do with a PRV. You can't do a bypass because again, it will be subjected to very high pressures. And where you have, PRVs in parallel, generally, this is also recommended by most of the courts where, depending on the characteristic, if you look at, the PRV characteristic here, you have suppose a 32 mm pipeline, you can see generally this is, the kind of PRV which needs to be provided. 32 mm pipeline, it gives a flow rate of roughly, you can see the bottom liters per minute. It gives around, I think by 10, 20, around 40 LPM of water with 32 mm dia, and with a 1.5 meter velocity per second, between 1 to 2 meter velocity per second, this gives this top one, whatever you can see. But what will happen, suppose this discharge comes down during night time, we assume it as 40 LPM, but night time it comes down to 0.4, 0.5, only one fellow is opening this tap. What will happen, this first one, whatever that PRV, it will never open. That 32 mm, it is stopped at around, you can see here around 20 LPM or somewhere at that location. But suppose your requirement is 8 LPM, it never opens up. They will not get any water. So that is one of the reasons you need to have one PRV for high flow, another PRV for the low flow. So this is the arrangement, what is important and what is being done. This is basically pressure drop across PRV. Now, so that is one of the reasons what we just discussed. Suppose you have only one pump which is taking care from 10 bar to 1 bar. 10 bar is the lowest guy and 1 bar is the topmost guy, what is they need pressure. And in case of hydromatic systems, and you will have to spend suppose 100% energy, then if you try to use two pumps, that means one is a high zone, other one is a low zone. They are working in parallel. The first thing here, it is not even high zone, low zone, it is only two pumps. What will happen is, even though there is a variable frequency drive, most of the variable frequency drives, they don't work less than 30% requirement. Suppose its flow rate is around 200 liters per minute. So naturally, or maybe 10 cubic meter per hour, we say 12 cubic meter per hour. So if it is less than 3.6 cubic meter per hour, it will not work satisfactorily. Suppose you have two pumps, then automatically first pump will work at 100%, which will have the highest efficiency, and second one will go up to maybe a lesser requirement, whatever it is. Again, that may be slightly less, but because its power requirement is less, because pump is, the total energy requirement is split up into two components. So there could be some good. So as you increase the number of pumps, then definitely your energy savings are going to increase. So if you look at it, this is basically to explain about the, and more than that, instead of this, suppose you create a different hydraulic zones, a low pressure zone and high pressure zone, both with different kind of pumps, number of pumps, then our energy savings will be substantial. And here I have shown you the other one already. Here we have done this kind of study in one of the projects where you can see this blue line is basically the water consumption and the red is the power consumption. And this other one is that the kilowatt, and the violet one is the energy consumption basically. So here what we have seen is, in this particular project, again, I'm telling you why I am trying to show you this kind of things are, basically there is a huge requirement for this kind of studies in the entire world. I can tell you within our reach, we could look at a lot of possibilities in saving energy, saving on pipeline material, saving on the water consumption and other things. Here what we have done is we try to understand the pumps generally are selected. How do we select the pumps and energy? We have different kind of fixtures. So what we call it as a water supply fixture unit, probably a tap may have around 2 or 3 as the fixture unit numbers. So we try to add up all these things in a plumbing fitting, inside a toilet, and then take out all the plumbing fixtures. What is that water supply fixture units? And there is a curve called Hunter curve. It was developed by Dr. Roy Hunter, as I told you, in 1940. How did he develop that curve? And probability, based on certain probability statistics and other things. And he also collected, he only decided about the size of the drainage pipe, size of the vent pipe and other things. He did a remarkable study in those days without much availability of technology and other things. And he has developed all these piping systems and the sizing of these systems. But his availability of data in those days is only for 10 floors or 11 floors or 12 floors, nothing beyond that. So, but what happened today, we are talking about 100 floors buildings, maybe, 300 meters, 400 meters, 500 meter tall buildings. Even India is going to see up to around 450 meter tall buildings. So in such kind of buildings, whether these studies really work, what I wanted to show you is, based on his statistics, generally, every plumbing consultant, we need to follow the National Building Code guidelines. And National Building Code talks about only the Hunter curve, that is basically based on the fixture units and developed by Roy Hunter. And if I work out based on that, this is a project of around 1120 apartments, 3-bedroom apartments, which are spaced out in around 20 floors. So this is such a huge project, and whatever the pumps provided are around 200 cubic meter per hour total. So what happened, the ring main sizing is done at 200 cubic meter per hour requirement at 1.5 meters per second velocity. So we work out what is the pipe sizing. Then what happened, whatever we see here, the total consumption of water, whatever it is, per the total project is around 4 lakh liters roughly. And when we have seen the power consumption for this, it takes around 336 units. The peak flow, what we found out is not more than around, you can see the spike, the 50 liters per hour for each apartment is what we have worked out is the maximum peak. But what is happening? Whatever the pumps we have, 4 numbers of 64 cubic meter per hour, where 3 are working and 1 is standby, out of that, on a non-working day, only 1 pump is working, and this is the time sharing of that pump. Flow rate, even though it is 64 cubic meter per hour, it is working up to 5 cubic meter per hour for almost 25% of the time. Another 25% of the time, it is at 10 cubic meter per hour. So that means how much it is? It is only around 1/6 or 1/12 of the requirement of the pump, where your the variable frequency drives will never work in efficient mode. So there is a very good demand to redesign the Hunter curve. Definitely, this is also being worked on by various other institutions like academic institutions, and I hope they will be able to come out with a better understanding of this kind of data, because today we have water meters for every apartment, every riser, so we can get a lot of data, and analysis is much better. So I am sure as students, I want you to develop that passion basically towards plumbing. And also plumbing means just it's not plumbing. There are a lot of new scientific methods which we need to use to save water and save energy and improve the health and improve the environment. So in this particular case, what we have seen is this is on a non-working day. On a working day, what we have seen is maximum 70 cubic. That means 1 pump is working fully, other pumping is working at only 4 cubic meter per hour. So because of this, we are getting an efficiency of the pumps not more than 5 to 8%, whereas they are supposed to be at around 55%. So 55 to 60%, today with a lot of high efficiency motor like IE3, IE4 and all, so it should have been much better, but that is not happening here. So in this particular case, what we thought is if we are able to reduce and deduce, not reduce, basically deduce the actual consumption by doing studies. I request all of you students to take the lead and then get the data and submit to IPA. And then what will happen, we can understand what should be the proper demand factors and then redefine the demand factors, and we can reduce our pumping capacities. Otherwise, you see where I need only 2 pumps rather of 30 cubic meter per hour or 40 cubic meter per hour, I have gone for 4 of 64 cubic meter. So, because we are forced to do as per the standards. So this is one study, and most of the studies are somewhere it's like that, where we are using a lot of energy, unnecessarily wasting energy in all these cases. And this is another project. And so here what we found out is, you can see here, even though there is a pump, I'll show you, I'll come back to one of these pumps here. You can see here, on a non-working day, for example, 50% of the time it is working at 10 cubic meter per hour, whereas our pump works efficiently even with a VFD with minimum 20 cubic meter per hour. So suppose instead of 64, I go for a small pump of around 10 cubic meter per hour, then it can work up to 3 cubic meter per hour. That means 30% of that without any loss on the efficiency, and it becomes much more better. So this is one of the developments that is happening. As first of all, hydromatic systems itself is a good development, and out of that, even this particular thing like a pilot pump has become really a useful thing. This is a typical, you can see 3 pumps are bigger and one is a smaller one. It's basically, it's also called as a jockey pump, it's called as a pilot pump, or you call it anything. That is one thing. And second thing is aerators. We talked about the high pressures, where in the system and trying to use PRVs. Suppose we avoid PRVs, and I mean, suppose up to 4 bar, 1 to 4 bar, even if there is a PRV, pressure regulating valve, pressure reducing valves, but still we have seen in one of the slides how with the pressure, the water consumption, water discharge can go high. But if you are able to control that discharge, here this is a pressure compensating aerators. Whatever, you see, this will be something like this. From 5 bar to almost up to 1 bar, 0.5 to 5 bar, it will have a very constant output without any trouble. So these kind of aerators are available today. So they will work very well with pressure compensating aerators basically. So whatever may be the inlet pressure, your flow or discharge out of the fitting or the fixture is fixed more or less. So there will not be any wastage of water. And these kind of water saving aerators, as a part of I Save Water, even IPA has distributed, as an awareness to a lot of members with this kind of pressure compensating aerators, and they have given a lot of savings in many projects. And it reduces, the moment we reduce the water consumption, see, we have seen that pressure compensating aerators, without impacting your discharge, without impacting your luxury in case of showers and other things, you can save almost 50 to 60% of water. It is not just 50 to 60% of water. When we are talking about it, the energy also is automatically, because energy is directly proportional to our water consumption, like discharge. So naturally, your energy also can come down. So this is the another thing what we need to note. And there are different kind of products, water efficient products, and IPA also has come out with a code called WPD, Water Efficiency Efficient Products India, which is also adopted by the Indian Green Building Council as a part of water efficient products, which are mandatory to use at least 30% water saving fixtures in every green building project. And we have seen one of the calculations there, how the energy consumption with the hydromatic system. If I do the same thing, the power consumption, it can come down by around 40% again. It was earlier, last one, if you see with 4 zones, it was around 4.9 units. Here it is 3.4 units. At least, 25 to 30% energy can come down by assuming that there is a reduction of at least 30 to 40% of water. And the next one is smart water meters. Smart, again, that's what I'm telling you. There's a lot of electronics, and then computations and statistics and analysis, data analysis. It's going to happen even in the case of water and wastewater. If we are able to get a lot of data, we'll be able to optimize a lot. Smart water metering, where you can have most of the meters are ultrasonic meters, and then you can get the data connected through building management systems, where we can have a display, we can try to analyze things, how the different timings. Whatever I have shown you is basically we used a portable water analyzer along with an energy analyzer, power analyzer. But here you can connect it on a bus, like RS for any kind of Modbus or BACnet or whatever the kind of protocols, and then you can get the entire data a central computer. This is what we have seen in something on the water supply. Now let us look at the wastewater systems. Generally, if you see any kind of plumbing system, it will be something like this, where you have what this is basically, I don't want to say it is not like this. There will be two different pipelines. One is for soil waste. Soil waste is what is the waste that comes out from the WC, water closets, because that has got a lot of waste which is coming out of the human excreta. And the other one is like a limited wastage, like your showers and then wash basins. It's more or less like a regular water kind of things, or urinals and other things. So that will be like a waste line, it is called. The other one is soil line. So generally we'll have two separate stacks. Waste stack is separate, soil stack is separate, and we'll have one more piping for the ventilation of this particular. That also we'll talk in the next one. Basically venting of the pipe. Otherwise, if you don't vent it, there will be the only method of allowing. You can see here there is a small U. If you can see in the top one in the figure, what is this U? It is a water seal. So what will happen whenever there is a water coming out of this one, this water seal always maintains so that it will not allow any harmful gases to come out from the stack to the bathroom. This is what had happened for the spread of SARS virus in Hong Kong, where there is a water seal failure and that has spread out to the bathroom, and that created a problem for the people, and it spread out very fast. So this is water seal is very, very important. If you have to maintain not getting any kind of, this one, either we need to maintain an air gap in most of the things, in plumbing systems. I'm sure you might have been discussed about all these kind of things in the basic plumbing. 25 mm air gap to be maintained, and then water seal. So whereas the latest development, that means we'll have three pipelines. One is soil stack, waste stack, and vent stack. Soil, waste, and vent. This is what is generally called. So the three things, now they are all combined with one piping, which is called a stack aerator. So different companies have got this kind of stack aerators. You can see this kind of fitting where, the horizontal pipe, whatever you can see, the wastewater can come through this, and the top one, whatever it is there, that will go without any obstruction. It will go out and it will not create any kind of negative pressures in this system. Generally, why we need to have a vent stack is, it is not many people, you see the three different pipings, either your stacks are vented, or otherwise we'll also have a separate vent stack. This separate vent stack is required to maintain water seals intact. I have shown you here. What will happen is, whenever there is somebody is flushing the toilet, when you are flushing a toilet, water gets into the vertical line. It will try to, this water, whatever the wastewater, it will try to entrain the air also along with that. So the moment it entrains the air, there will be a negative pressure created. Once there is a negative pressure, then it will suck out wherever there is, whatever air is there. Along with the air, even water also will come out, water seals will break. So that's why you have to, whenever there is a negative suction created, we need to make sure that there is proper air entry into that particular thing. Whereas in case of stack aerators, this itself will create the kind of, there will be a barrier almost, where there is no way. When somebody is flushing here, it is going through the waste, it cannot create any kind of negative pressure here. It will be, so the stack itself will have its own venting. So what will happen, instead of three pipes, we'll have only single pipe with this kind of aerator. Now, of course, you can see here, this backflow, whatever the pressure relief branch and other things, today they are not required because a lot of new developments have also taken place. This is slightly a older version of it. Today they can do without a pressure relief branch also. So that means there is only one pipe which is coming down with this kind of stack aerator. So what will happen? You are saving on the material. Most important, you are saving on the space, because three pipes needs almost 600, 750 mm, 200, 2.5 feet of space. Now it can come down to only 1 feet. So a lot of space can be optimized, a lot of maintenance can be reduced. Not only this, there is another system. I'll come back to siphonic. See, this is called air admittance valves. See, this is another type of system. When we are venting a fixture, we are taking a vent from the top. Air is coming from the top. Suppose you provide a vent, what you are seeing here in the second thing, you are putting a small air inductor. Air admittance valves or air inductors, they are called. Because whenever there is a negative pressure, this can create a sort of, it can open up and then it can give the air into the pipeline system. Suppose you provide this near every bathroom or something like that, then automatically the requirement on the stack can come down. So whenever there is a negative pressure, it will allow the air. Whenever it is not required, it will close off. So something like this. You have a wash basin, how this air admittance valve. If that kind of things are provided, I'm sure that, with the air admittance valves, you can avoid the vent stack, and you can again go for a single stack system. You don't need to have separate soil stack and waste stack and vent stack. You will have only one pipe, that is soil come waste and vent, everything together with only these kind of things. There are also, along with this, there will be something else called, I'm just checking here. Yeah, every 5 floors, you also provide something called PAPA valves, that is positive air pressure attenuators. What will happen is, whenever there is a positive air pressure, this is something like a bellow. When we go to the water hammer arresters, we can also see that will hold the air and it will releases the air, so that the stack requirement comes down drastically. So this is another development which is, with a single stack, where we can try to reduce the lot of space. And one more thing is siphonic roof drainage. Generally, what will happen when there is a ray of water roof, you try to take pipeline, and then the pipeline sizing is done basically with the heavy rains or whatever may be the rain. The only around the pipe 40% or something is supposed to be covered with water, and the rest air is required for it to flow down. But whereas in case of siphonic drain, they try to assume that the entire pipeline can be filled with water. So that means you are trying to reduce the number of downtakes by allowing the pipe to take more water using the siphonic action. So by doing that, you can cover a larger footprint with the same number of pipes. That is one thing which can be done. And so there will be reduction of, again, material, reduction of shafts and other things. So this is how the pipes can be organized. And there will be many roof, see, you can see here, there are too many outlets, because generally based on the rainfall, there is a formula which is used to work out the pipe size. NBC also has given a table for that. Suppose, at 50 mm per hour, it can cover probably 110 mm dia pipe can cover around 85 square meters of roof area, 85 to 90 square meters of roof area. So, whereas this particular thing can go almost 2 to 3 times size of that. So the number of downtakes, and then it can come down with only like a plumbing stack, it can come down with one water line. So that we can look at it that the number of pipes can be brought down drastically. So siphonic drain systems is another thing. And one more thing where generally, we find problems is a lot of surges that happens in the water supply line. Say when sudden switching off, you take any kind of thing. So what will happen when you suddenly apply a brake on the your bike? It will try to take a jerk, because that entire energy has to be dissipated within no time. There will be some sort of a back pressure that can happen. In case of closed pipeline, suppose you have a free flow of water happening through a tap, but suddenly the valve gets closed. Generally, when you are trying to operate with a normal hand, it takes some time. It takes around 20 seconds or so. But whereas if there are, today we have electronic valves like solenoid valves, they suddenly stop it. The moment it suddenly closes the valve, there will be a lot of back pressure into the system. And this pressure, depending on the velocity of the, whatever the velocity of the water in the pipeline, it can go up to almost 60 times its pressure. That means suppose you design your system at around 3 bar, you assume at one particular location, it can go up to 180 bar. Suddenly the valve, a simple valve closure can create that kind of pressures. So if what will happen, if that kind of pressure happen, your fittings will give away, your pipes can break, any kind of valves can give away. So this creates, this kind of transients. This is a very, very short duration transient. I'll also show you how it is. So when the water is flowing here, there is a solenoid valve which is immediately suddenly closed. There will be water flow back, because water is a non-compressible liquid. Please understand, you cannot compress water. So our air, it will automatically, it will try to flow back, and there will be heavy noise created, and also there will be a loud bang of sound. Along with that, the huge amount of pressure that is applied. So the 300 to 600 psi is almost like 30 to 40 bar of pressure it can create between 1.5 to 2 meters per second of velocity. This is some of the studies which were done by some of the research institutions. So to avoid that, what you need to do, you have to have some sort of a water hammer. It's called water hammer. Water hammer arresters have to be provided. It could be, see, what causes this kind of water hammers? Generally, you see solenoid valves which are provided in the dishwashers, washing machines, and flushing valves, urinals, toilets, and other things. So these are some of the things. And then how these things work? They try to, they're like, whenever there is this is the noise that is created. So you try to provide a bellow kind of thing or a pipeline which releases that pressure suddenly, then the wave can be reduced. So there are different sizing arrangement and placing arrangement for this one. And the next one is, the waste, solid waste management. The solid waste is also part of our plumbing requirements, where, out of that solid waste, generally around 0.5 kgs or 0.4 kgs per person is produced per day. The total wastage, out of that 40% is considered to be the wet waste or kitchen waste. So that can go into an organic waste converter. It can be converted into manure, which can be reused for the benefit of the society for landscaping and other things. And another important thing that happened is, with respect to the sewage treatment plants, there are different type of sewage treatment plants. Earlier, if you look at it, we used to have aerated submerged, aeration ponds. So where it used to occupy a lot of space. Now today, the entire thing has been brought down because here the power consumption has increased. The size of the plants have reduced naturally, and they can give very clear water output. So the MBRs, membrane bioreactors, this is one of the recent developments which is being used in many projects today, which can give very clear, because the water, whatever the sewage after the aeration and pre-treatment, it will go to a membrane tank where it will suck out through membranes. The water, with a very high pressure pump, it will be sucked out through membranes. So naturally, most of the suspended solids and then lot of organic material and other things will be taken out. So naturally, we get very clear water, and the biological oxygen demand, which is one of the parameters for looking at the efficiency of the STPs, it can be between 5 to 5.5, whereas our National Green Tribunal standards, they say less than 10. So it gives better quality than whatever the standards. And suspended solids and ammonia will be nil, and it will be free of pathogens, viruses, and bacteria. So this is from UNESCO. They have made a comparison of different type of water treatment plants. So out of that, you can look at effluent quality of the MBR. It's very, very high. And BOD removal is very high. None of the other plants, you have different kind of plants, none of those things are really high. And naturally, the energy use also is very high. So this is, this is what we call it as the water and energy nexus. There is, wherever the water qualities are to be improvised, naturally, the energy consumptions will be generally high. And next one is hot water systems. I'll try to wrap it very fast because I think I'm running out of my time. Don't worry, I think we'll try to complete as much as fast as possible. And so we generally look at solar hot water systems and heat pumps. Otherwise, we generally use geysers. Geysers is one thing where coefficient of performance is 1. Then heat pump will have a coefficient performance of around 4.2. So naturally, the power requirement for the same amount of hot water to the same temperature rise is very, very less, 4 times less. And solar hot water, I'm sure everybody is aware of that, and there are a lot of developments that have happened in this. The next one is in the piping material itself. There are, different type of piping. Earlier days, if you see, I'm sure your generation probably would not have seen, but earlier we used to see a lot of GI pipes which were used in the buildings for the plumbing, either within the toilets or for the vertical lines. But today we have a lot of developments like composite pipes, which can come in rolls so that the number of joints could be reduced. They will have, with polyethylene cross-linked kind of material. with aluminum pipe tubing for giving the mechanical strength, and they can be used. Most of these plastic pipes can be used without any trouble up to 10 to 12 bar of pressure, but the fittings and other things generally they are restricted up to 8 bar. So you cannot use for very high rise applications unless you break your pressures. And composite pipes, they have even they can take care of the high temperature requirements and high pressure up to 11 to 12 bar, and they can be used for various applications. I'm sure you also have seen our sponsors video KPT, who have talked about PPR pipes. That also is one of the latest pipes. You see here, we covered even the PPR pipes, which are also can be used for temperatures up to 95 degrees. And then this is one of the, it can be used effectively for hot and cold water plumbing systems. And this is used mostly in, outside the country, like Middle East and all. It's very popular. Unfortunately, it's not highly popular in India, but I think now people are coming to that. And now the next one is hubless cast iron. This is basically wastewater piping, where the wastewater piping, either CI, earlier we used to use cast iron pipes, because the waste itself will be highly corrosive in nature, and normal MS pipes or GA pipes cannot be used naturally. So they used to use cast iron pipes, and it's very difficult. They used to come earlier with lead joints. We used to pour, make the lead liquid and then pour into the joint to make a proper joint. But lead is not environmental friendly. So today we get hubless pipes where you can do a mechanical joint by tightening the clamps. So these kind of pipes have become really useful, and they will have very smooth flow of for the water and other things, and jointing and assemblies can take really a good pressure and other things, and they also look neat and they are sturdy. And we discussed about PPR pipes, and HDPE is another high density polyethylene or medium density polyethylene, and LDPE, low density polyethylene, is not used generally in water and wastewater applications, but HDPE can be used. We have seen the stack aerators earlier. They're all mostly, and UPVC is another pipe which is used, and HDPE pipes can be used up to 80 degrees centigrade of temperature, and they also, can have welded joints, and they are really long life. Almost, most of these piping systems today, we can talk about around 50 years plus, whereas, earlier GI pipes and other things, they never used to have a life beyond 10 to 12 years. So the different characteristics of the HDPE pipes. I hope, thanks to, first of all, the Dr. Veerappan and Praveen Bora, who made the basic of these slides. And that is what I wanted to thank them for that. This is part of the IPPL presentations, and I have done some modifications, for educating you onto this. I hope it's very difficult for you to grasp all these things in this one session, but there could be continuous sessions. I'm sure Milind and Dr. Veerappan will try to do a number of sessions where everything could be explained in maybe smaller intervals for a number of times, so that it can sink in very well with all of you. Thank you, everybody. First of all, Milind and Dr. Veerappan and IPA for giving me this opportunity to share some of these things. And all the best to all of you. If you have any questions, you are most welcome to talk to me right now, or otherwise you can send them to Mr. Milind or IPA at any point of time. We'll be there to support you. Please take plumbing as a passion and as a profession. This is what our request. Please. Thank you very much. Good day.
Excellent, sir. Santosh is there? Santosh?
Yes, sir. Thank you so much, sir, for sharing such a wonderful session. And now I would like to invite Mr. Veerappan, sir.
Yeah,
He will ask questions
on
behalf of students.
Yeah. Thank you, Santosh, and good evening to one and all. And almost now 6:45. Sir, small corrections. You have told some correction. No, lot of corrections you have made in the slide.
No. Please understand. I have only tried to bring them back and forth to my convenience.
Excellent, sir. So no. Please understand, excellent, because the case studies, the working to suit the students, you have made it. Wonderful, sir. Wonderful.
See, I have the other which I have to do in the last 10 minutes. Let me tell you honestly, because some of the case studies were in different locations.
Sir,
I didn't get time to do that.
we are acknowledging your effort, the way in which you have done, the way in which
Thank
you have taken the presentation to the next level. It's a only thing, little worry is, I think Vilen has to take it very seriously. The student, I'm seeing only 18, including me. I have to now go back and see why this is happening. 18, 19 students, unacceptable. Even if it is coming one, if you ask me, I will take a stick on my hand and do the, this thing, because students see the effort is being brought by IPA is it is unmeasurable, sir. I'm telling you, unmeasurable, and it's a wonderful platform for the students. See, numbers can be say, even if we have some 10 chapters, assuming 50 students are doing it, 500 students has to be present. So please, we need to go into that approach and see where we are going wrong. In particular, all NEC members, because see, NEC members and NEB members are the key to this IPA success. But to be frank, Mr. Convener, I am putting this in an open, platform. We need to take it very seriously and move forward this. Okay, sir? Because the way in which you have designed this student chapter PPT or student chapter topics, 4 topics, 4 different expert speakers, this is.
I think, Virappan, we need
up to you, sir. Hands up to you, sir.
This we need to contemplate when we sit in the NEC or in person.
Yes.
Not in at this forum, I suppose, but definitely
okay.
your points and concerns are well addressed. I too, what I have written in the NEC. So let us not take this forward anymore and go ahead as per the protocol, I think. So.
No, that is okay. That we will move forward, and thanks to particularly to the convener for bringing this IPA chapter to a different level by designing the students for the students at 4 topics, okay, given by the different speakers. Thanks to the WPC chairman who has been came on the video by stating the statement or quote, plumbing is vital to the health part of it. And thanks to Mr. Srinivas sir, thank you very much, sir, for giving a very wonderful opportunity for a wonderful topic and wonderful speech on these various points, particularly the sources, conservation, water efficient products, and the modern materials like PVC pipes, HDPE pipes, all those pipes, and it will give you those people who have watched this, they will definitely become an entrepreneur in future. Not even they will go for the design.
See, out of this whole program, even if we get at least 15-20 people getting into plumbing profession, I think our efforts are.
This is what even Dr. Sunil Kute said, even Rahul said. 5% is more than enough.
More than sufficient. Yes.
Sir, coming to question, one session which we have not even one question have come, but I will put forth one question to you, sir.
Tell me, I hope I will be able to answer, Dr. Veerappan.
No. From the residential point of view only, from the house part of only. Sir, AC water is coming. Suppose 3 bedrooms are there. 3 AC water is coming. This condensate water, you don't know what is happening. Everything going waste. Just like that, people are setting it out. That is one. And everywhere people are having aquaguard. That water also going waste. These 2 waters also, I hope it is part of your recycling. How to make it happen in small houses? This can you answer so that it will go to the students?
I'll tell you one thing, sir. Because first of all, we need to understand the condensation will be much higher where, in case of humid climates, where you will be able to take out a lot of water from the process. So naturally, like your place, for example, probably you can generate a lot of condensate. And not only that, what will happen is even 1 house or 2 house or 3 house, 1 AC or 2 or 3 ACs in a house, definitely they produce some amount of water. So we need to make sure that the pipelines are segregated and collect that water. If it gives even 2 bottles of water every day, I mean, every night you are using 1 or 2 ACs. If you are getting 1 bottle of water, our efforts are fruitful, sir. And what we are doing is, let me tell you, for the projects, especially today, like apartment projects and other things or hospitals, we make the piping separate completely. And then all the complete condensate drains are taken and then collected into a common. Again, the only thing what we are doing is we are putting back into raw water tanks. And then it will go for treatment, because some cases we are worried that, some ACs, some leakage of oil and other things probably may get contaminated with that water. That is one issue. The second thing, whatever the question, I'm sure, like I told you, Burj Khalifa, I had seen myself, around 380,000 or 4 lakh liters of water is saved every day because of water, condensate water. Only air conditioning condensate.
Good, very good.
Huge amount of water they save. So that should be a practice in every project. I think IPA should take it up strongly. But one thing, in all these things, that is where I request students to come forward.
Yes,
They can go and collect some data. How much water is getting generated? How much condensate is being produced in some particular regions? If they take the data, then we can try to understand what is the scope and what is the amount of water that can be saved by doing this. So I think, because today people are not fully aware of the potential, because Burj Khalifa, it is such a tall building. So people, 4 lakh liters, everybody thinks, yeah, it's good. But in our buildings also, there is a huge potential. And second thing is, you talked about, I think, portable RO, I think, not AquaGuard. AquaGuard will not waste any water. Generally, RO is, in fact, we have been advising every client that don't use RO. First of all, RO is not good for health. It's a dead water. This is, one thing which we need to, I think I have not missed out in this particular presentation. It's good that you reminded me. I will add it up for future. And definitely RO, for the benefit of every student, I would like to say, it wastes almost 60% of the water. And that too, that water will have very high contamination, with respect to the solid, the suspended TDS and other things. So naturally, the salts and other things. So naturally, that water cannot be even put back into STPs. But naturally, today, that is what is happening, because that is going into, otherwise, it is increasing and the hardness of the water. And again, we need to put a softener even after the treatment. So ROs should not be used. Forget about saving of RO water, reject. But we should never encourage RO. Even WHO is very clear, it should not be used. One point I want to tell you, there is a technical paper by WHO itself, which says if this water is given to plants, plants will die within no time.
Correct. Very
So
good.
if that is the case, what will happen to our intestines? We also die very fast. Only thing is, we may have better, resistance and immunity, but plants are so delicate, they can't sustain for a longer duration. So that's the reason RO should never be used, and we should not talk about any wastage further on that. This is what my opinion.
Srinivas, but there are
Thank you very much.
Sorry, last question, rather a supplementary question. See, when you see TDS at a level of 1600, 1800 and hardness to a level of 800, 900, then you don't have any other alternative but to use RO.
See, there also, right, Milind, I agree, where, our 10,500 recommends where there is no alternate water, you can go for a TDS up to 2000. Okay, 1800, 900 also acceptable as a potable water standard. It's only, giving some sort of stains and other things on the fixtures. That is one problem.
What happens is hot water lines and even to an extent cold water lines, the scaling is so fast. We also have this kind of problems in certain areas, especially. Yeah. What you try to do is reduce don't do the entire RO water. You try to do whatever minimum required to bring it down to around 500 and use regular water beyond that. So then, naturally, if this one is around 1500 or 1600, you have to use in 3:1 ratio. Then only you will be able to bring it down to a level of less than 500. Yeah.
So there is no option. I agree. I mean, only in such cases.
Sometimes, it's really agonizing to use RO, but then sometimes it becomes compulsive case.
No, even in such cases, one is, wastage of water. Second part is, the health. So they have to make sure that add some minerals again into the water.
Yeah, that is correct.
So that is another thing which we need to do. You are asking something, sir, Dr. Veerappan?
No, thank you very much, sir, because, I think some students are all waiting, and thank you very much for your clarification. And you have, made an eye-opening, as eye-opening for the students who have listened today, because you have every student will be focusing on only structural design, structural analysis, structural this one. But now you have given them an idea to give, to collect the data from various sources, various buildings under water analysis with the energy consumption. This
Sir,
point itself is more than sufficient.
Sir, there,
Yes, sir.
if somebody can go through, there is, there is a website in, I think, IAPMO's website, where there are 142 research projects which are waiting for people to take it up.
Beautiful, sir,
On the plumbing, with respect to these kind of studies. And it will
We will
help
take it
the
up, sir.
entire world. I'm telling you, not only India. India, we have huge consumption as such. But other than that, entire world, it will be helpful, because nowhere it is being done.
We will guide the students accordingly, sir. That's why we are all here to, have a, that's why IPA, is the platform to, bring the students to our standards. Okay, sir. Thank you, Srinivas, sir.
Thank you. My pleasure, sir.
Thank you.
From
Thank you.
Hyderabad, good exchange of, information. And finally, thanks to Santosh and the entire HQ team who have been fully designed and for all these days struggling and organizing such a wonderful webinars. Okay, final thanks to Mr. Milan Shetty ji and the entire office team for coordinating this event, and end to the students who are all participated and enjoyed this session. Thank you, one and all.
Thank you. Bye-bye.
Thank you.
Thank
Bye-bye.
you. Thank
Bye,
you, sir.
Srinivas. Thank you.
Thank you. Bye. Good day.